Yes, Jackson, you can give us the opening prayer and we begin. So let me hope people are seeing my screen. Yes.
So let's pray. Dear loving Father, we want to thank you for this morning. We want to thank you for the gift of life. We want to thank you for your protection, for your mercy upon us, that we are here this day to have our lesson. Father, we pray that may you bless us, may you give us the knowledge, wisdom, and understanding, that we may be able to understand what Jesus communicates us. May you bless him and may we be able to understand. We pray and we believe in the mighty name of the Father, the Son, and the Holy Spirit. Amen.
Okay, thank you so much, Jackson, for that word of prayer. So you all know that we always begin our lessons by looking at the syllabus book to look at what exactly is supposed to be covered. Let me know people have their calculators ready. I struggled with people in the previous lesson of polynomials. Let me hope it's not the same case. Okay. So, probability, what we are going to cover is called discrete probability or discrete random variables. That is under random variables. It is topic 14. I remember telling you the other holiday, I shared the syllabus books, but students complained that they were not so clear. So I decided to come up with my own. I sat down and organized this. It is so student friendly. And I only share it to students who are organized, students who come early for lessons, students who keep time. I cannot share my good work to students who are not focused. Parasites. Okay. Now, as I've said, it is topic 14, and it is the second topic of Senior 5 Term 3. As you can see, this is Senior 5 Term 3 work. Yeah. Topic 13, series. Topic 14, don't say that, but we covered it in second term. It depends on how people want to cover their work. There are some of you that have not covered topics like partial fractions, yet they were topics of term 1. So it depends on how people want to cover these things. Personally, I always try my level best to just follow the book, but ensuring that next holiday, the work is done. So before we even go through what we are supposed to cover under discrete random variables or just simply discrete probability, we'll brief you a bit. When you look at this topic, it's topic 14. I remember telling you that you're supposed to plan well. And when you fail to follow your plan, you are simply planning to fail. So under these random variables, of course, you should have a simple introduction, which introduction I'll shift to discrete and cover it at once. After all, discrete comes after introduction. So after discrete, the other topic that is supposed to come next is called continuous. You understand? And after continuous, the next topic is probability distribution. I remember telling you that during the course of the term, there were people I was actually teaching. Said that when you people are back from school, you can cover work at a very high speed because the goal is to complete work next holiday so that you have a full year to revise. I always say that. Now you realize that I'm going to take my time to cover this discrete. Why? We already covered continuous random variable with those people. Continuous random variables, they were already covered, but you can see they are supposed to come next. Then the next topic, 15, is probability distribution. When I share these books, I want you to sit down. Just like you read other things, sit down and read this student-friendly syllabus book. Have the topics in mind. If you people can cram episodes of seasons of series and what, you cannot fail to be like, under this topic, this is what we want. This topic comes after this. You can sit down every time you have that. You literally easy to plan. But failure to know this, you just handle things anyhow. You don't have an exam plan. You just there disorganized. And of course, you cannot get planned results. So even these topics that are coming next, these things of binomial distribution we studied, normal distribution we studied. I decided to leave out rectangular for this holiday. But I've told you that binomial is already there. Normal distribution is already there. But this is under topic what? 15. Then what we are handling right now is topic 14. And we are starting with discrete. That is today or now. But what is supposed to come after discrete is continuous. Which continuous is already there. And I told you that our work is always accessed at 2 platforms. I always don't get time to say this in WhatsApp groups. I always want to say it when people are on so that they understand that. So it is two-way. Those who may need to have a look at the continuous and the other topics, maybe after this. We have 2 ways in which you can try to access that work. So we have our drive, as you can see on the screen. So under here, Senior 5 Principal Math folder, I've said this is term 3 work, so I'll come here term 3 work, and I've said that is under random variables. So under random variables, you can see under discrete, but are people seeing my screen? I've said that, let me hope it's now okay. I've said that, and we have this Principal Math folder, and we have agreed that is term 3 work. So I'll come here term 3 work. And it is topic 14, random variables. So I'll come there. And random variables are to the discrete and the continuous. So when you come here on discrete, discrete has nothing there because it has not been taught. But when you come here under continuous, you can see there the lessons are 5. You have lesson 1, lesson 2, lesson 3, lesson 4, lesson 5. And they were completed. Those of you can see the date here. It is May something 2025. The modified date. So that was covered, continuous. Then the other topic after random variables, we have said it is topic 15, as you can see. After random variables, it is probability distributions. So when you come under probability distributions, there are 3. Binomial distribution, uniform distribution, normal distribution. These are the things that are going to dominate next term. So you have to prepare very well because most of you never exceeded continuous. If I told you covered something about distributions, you only covered binomial. I doubt if any school covered normal. Then that is the fastest school ever. So you need to cover this work because under binomial we have there the lesson. It is there. It is only 1 and the binomial was covered to the dot. We shall just revisit it maybe to revise, but we shall have to revise scenarios and a few computation tasks. Still under probability distribution, I've told you uniform has nothing there because you're supposed to cover it together this holiday. Then under normal distribution, you can see we have there lesson 1, lesson 2, and lesson 3. And normal was completed according to that very book, the syllabus book that we follow. Work was already there. And I don't want to repeat that. Maybe revisiting it to revise. So even Form 6 work, the same. I don't want to go into those. Those who have been watching recordings, you are aware that that work is present. I always just want to talk about specific work. Then those who may not have access to the drive, because it is me to grant you access. I told you just get time, simply go to our website. You simply go to our website and see that work. This is our website. So you can see this is Senior 5 Math package, Senior 5 Math work. You just simply press there and start learning, if at all you've purchased the course. So when you come here under course content, we have agreed it is term 3 work. So you can see Senior 5 term 3 work. Topic 13 is series. We have nothing there. Topic 14, that's where we have the, you can see, discrete, nothing is there. But under continuous, you can see lesson 1, lesson 2, lesson 3, lesson 4, lesson 5. Lesson 1 is 2 hours, 40 minutes. The second is 3 hours, 10 minutes. 2 hours, 16, 1 hour. So in about 10 hours, that is in a day, you're done with continuous. You sit down, revise that work, and the goal is to complete this work early enough, revise the whole year, pass UNEB, go to campus with government sponsorship, reach there and do your things. Just do what you want. Because parents will not even be following you up because you have a government sponsorship. So you sit down and concentrate on your future and do the needful, because after all you'll be next to your 20s. So topic 15 is also there, binomial distribution, sorry, probability distribution. Binomial, the work is there. Uniform or rectangular, I've agreed we are covering that together. Then normal distribution, we have there 3 lessons. So whatever is on the side is also on the drive. You just choose what you want. Our website, just go to Google, just go anywhere, go to Chrome and just put in p.m.f.online.com. Even if you just put CMOS, they will bring those things. So that you don't need, what I'm trying to prevent, people oversend me messages, I fail to reply some, yet what people want are things on the site. All books you need are there. You just go to the e-library section. So I don't want after this lesson to over disturb me, sending me messages. So how can I get this work? You go to the site. I'm going to send you a video on how you can access everything fully, but that will be later. Okay, so I think now we can begin our lesson in peace. Okay. Now today's concern is about discrete random variables. This one here is simply application, yeah? And you all know from chemistry that anything to do with application is always your research. I don't handle that, unfortunately. At least you also contribute something. Most of you are aware that your teachers are teaching you like the way you're supposed to be taught. They unpack learning outcomes for you. You go and make your research, you present, they comment, and topic done. So whatever we are doing right now is malpractice and not allowed by the curriculum. But some of us who have been in the system for some time, we know how hard it is for a student to introduce themselves to something with 100% unfamiliar terms. It is something that is next to impossible. But we are going to rectify that. So this is our focus today. This is a student-friendly extract from the current syllabus book. So we are not supposed to cover anything outside this. Okay, so we shall begin with, of course, describing what a discrete random variable is. Hope you're seeing my screen, the workbook. Then we shall explain the properties of the probability mass function. Shall talk about it. We shall see how probabilities are supposed to be determined. Then we shall look at how measures of central location. Measures of central location are those mean, median, mode, those to do with discrete values, those to do with average points. Then there are what they call measures of dispersion, like ranges, the variance, and the sister standard deviation. Then we shall see how a probability mass function is supposed to be sketched. Then we shall look at the C.D.F, that is capital F of X of discrete random variables. So today, my personal goal as the tutor, I don't want to cover the C.D.F, which is capital F. I want us to concentrate on the small f. You know, this p.m.f is small f, as I'm going to educate you. Then the C.D.F is capital F, but we are going to talk about all that. So literally, may I just want us to focus on this. for lesson 1. Yes. So our students are supposed to always have this book and always follow up lessons. Because in the workbook, I'm going to just say that lesson targets under lesson targets, I just want us to cover A, B, let me just say and C. A, B, and C. Of the student's syllabus book, yes. Only those three. They're the ones I want to concentrate on. Describing everything, properties, determining, and maybe simple sketching. Then C.D.F will come later. Applications shall be your take-home assignment. Continuous already uploaded. Okay, so I think we can proceed in peace. So, about the introduction, I've said that instead of a discrete probability, it can be discrete random variables. So in case it's not if the topic is not called discrete probability, they can replace probability with random variables. Said that the topic is discrete random variable. So when you find that somewhere, I don't want you to be so surprised. So concerning the introduction, those who attended with us polynomials, I remember we defined very well what a variable is, and I'm not willing to repeat. We talked something about a variable. So we say that a variable is something that keeps on changing to an extent that we may not know its exact value. You understand? So in this topic, the random variable is usually the variable. Before I even talk about random, you people, you know why we are saying random? Because we are dealing with probability. You're just measuring the chance of an event happening. So things are supposed to be random. But concerning variable, those who attended polynomials, is that value that keeps on changing. So we may not know its exact values. So here the variable, I've not said always, but usually x, and it is capital. Yes, usually x, and it is capital. So you always see that random variable x, and it is capital. So since its values keep on changing, or if it keeps on changing values, we may not know its exact value of x. What do they mean? That at one morning, like today, it will be x1. The moment I write that x with C's that are facing each other, that is small x. When I do this, it is capital X. When I do this, it is small x. Hope you are aware. So don't mind about the size. So even when I do this and this is still capital X, this is small x. So at one morning, it can be that x. Some other time, it can be another x value. Another time, because we are not sure what exactly this value is, another time it can be that. Another time, it can be that. Another time, it can be that. etc. Because we are not sure. etc. So these values are always specific. Someone may be like, what do you mean by specific values of x? What I mean by specific, they have their own range that is respected. They have a fixed range in most cases. As you can see, I only mentioned x1, x2, x3, x4, x5, period. Trying to show you that these values are so specific and they always have a fixed range, which is from x1 to x5. And they usually, let me leave my screen, and they usually don't exceed that range. So whichever range we are going to be using in Discrete is going to be respected and applied in calculations. First, appreciate that. One known variable is capital X. Variable means changing values. A case in point, small x1 up to x5. Since that's where I've stopped, meaning we follow a fixed range, hence these values are specific. Period. Okay. Now, those who attended our first lessons of probability under probability theory, we said that what they call probability space is a total of all possible outcomes You read a lot of books and they will tell you, when you go to our library on the site, you'll find books in case you want to make research. They will tell you that the probability or possibility space of a discrete random variable is supposed to be countable. Yes, just like we've said, but I said in a lot of English in mathematics brings a lot of confusion. So when they say it is countable, you just relate it to fixed range. After all, the range is fixed. That means we can simply find time and count our outcomes, period. Don't go beyond that. Don't overthink. What are the examples of discrete random variables in real life? Please, Bridget has leave my screen. Examples of discrete random variable in real life. Maybe there you may get the point. Which point do I want to talk about? That as far as discrete random variables or discrete probability is concerned, the possibility space is supposed to be countable. And that's why we follow what? A fixed range. Why I'm bringing out the thing of countable, I want to give you some of the examples of the discrete random variables. What are those examples of discrete random variables? So I'll say examples include like the number of people or number of students in a school. It can be number of mature pine trees, maybe in a given forest. It can be number of zebras in a national park. You understand? anything that is countable, provided the possibility of outcomes can be counted, just take that as a discrete random variable. Yes, it would be very good if you had project work under this, but unfortunately you don't. But at least you learn that. Number of students in a school, you can count them, so discrete. Number of maybe pine trees in a forest. That the forest has so many trees, but for you, you're interested in the pine type. The school has so many kinds of people, administrators, teachers, non-teaching staff, but for you, you're interested in the number of students. So number of pine trees in a forest, etc. But the whole thing is about a countable possibility, what? Space. Okay. And now, please, you leave my screen. Who is writing in the screen? I think I'm soon getting a moderator. Whoever writes in the screen, you remove them from the meeting. I think that would be the best thing. Otherwise, I want to show you how this topic is divided so that we have a sense of direction, as I always say. So this topic has the part of probability distribution functions. Yes, because the topic is discrete. So it has where we shall talk about the probability distribution function. Probability function, which they abbreviate as p.d.f. But we shall see at a certain point where they call where we have something like probability density function, and I'll explain that too. But you should know that this one at one moment in time is treated the same as p.m.f. Those who have been following, where this m is for mass. Yes, probability, this is function. So in the middle, it is mass. Then the other part, and this is what we are going to concentrate on today. So this one is the basic thing today. Then the other thing concerns the cumulative. Yes, we call cumulative distribution function. Which is the C.D.F. Remember telling you the C.D.F. cumulative, that one is supposed to be capital F of X. That one I'm not repeating, I'll never repeat. Then this p.d.f, those things of p.m.f, p.d.f, I mean, you see p, it is small f of X. That's how they distinguish them in probability. Cumulative, capital. p.d.f, just small f. But both of them, the x's are small for reasons that you know. Period. You learn that at least. And then the other things are, those ones will come later. But basically, that's how the topic is divided. p.m.f or p.d.f, then c.d.f. You know the full forms, you know the difference in the notation. So I think now we can begin. So when I say discrete probability distribution, you know what it means? Come and say. That is the simple intro. Discrete probability distribution. I need a chat secretary in case there is something that needs my urgent attention. In the chat, you raise up your hand and say it. If things are not that urgent, we ignore and we continue. I don't want to get distracted. Okay. So now know that we have finally attacked the PDF, or what people may call, or what people may treat the same as the p.m.f, for reasons that you know. Now, I want you to recall that X takes on a given, or I can say specific range of X values, say X1, X2, X3, let me be uniform, X4 and X5, just that. And then I remember telling you that this X is what we call the what? The random variable. And we said something about it. Joshua Bright, you remove what you've put in the screen. Yes, thank you. So don't forget that. It's just a simple recall. So with that, I want to tell you that it's these values, these ones, I want you to note that it's only those values, it's only those values that can be used, it's only those values that can be used, it's only those values that can be used to generate probabilities, to generate otherwise or elsewhere. Probability is 0. I want someone to tell me, what do I mean by the word otherwise or elsewhere? Who can tell me? Who can tell me? Who can tell me? Those of you who know some good English. When I say that it's only those values that can be used to generate probabilities, then I say otherwise or elsewhere. What do I mean? Yes, Joshua Bright. What do you have to say about that?
I think that could mean in a different case.
In a different case, of I can mean other values.
Otherwise,
Other values that are not x1, x2, x3, x4, and x5. You people, that's all you need in this topic. If you can give those statements time and get them, you'll never find issues in this topic, I assure you. Understand? Capital X is a random variable. It takes on a given range of x values, small x. Example, x1 to x5. Why we call them specific? It's only those. Why do we call them specific or special? Because special comes from specific. Because it's only those that can generate probabilities. But in case you get any other values, x is 6, x is 7, x is 8, x is 9, x is 20, probability is just 0. We don't mind whether it's x a million, whether it's x 100, probability is just 0. Why? They are outside the range. Yes. Those values are rendered what? Outside the range. So because of that, probability is 0. Outside the range, probability is 0. And that is it. And that is it. Now, we've talked of things of functions. People want to know, how do these functions look like? I want us to write this function together, because most of you just copy these questions on the board, even copy them poorly. The other time I got a student who sent me such a number, but even the writing was poor. So I realized this person needs mentorship as far as writing a PDF is concerned. Okay, so as you're writing, you listen. How is a PDF written? Let me add on discrete, because you all know we have continuous after this. So I'll say, how is a discrete PDF written? Like what we are going to do here is convert the statements above into a function. We are simply going to convert the above statements into a function. Let me tell you, the solutions to these things are the easiest. In my entire life, have not come across something as easy as random variables and probability distributions. But they are the most failed by students. Why? They just want to cram question and its application, question and the answer, question, answer, which doesn't work. You literally need to have content first. Other things come later. So we are supposed to convert the above statements. So we are converting the above statements. We are converting the above statements into a PDF. You know what a PDF is. So this is what we do. Those are the statements. You read them once. I'm just giving you half a minute. You read them. Read them. Then I teach you how these things are written. You now have 15 seconds. Said half a minute. 30 seconds. You now have 10. Now have 8. Okay. Let us write it together. How do they convert? We have said our role is to get probabilities. Our role is to get probabilities for a given random variable, capital X. I told you it is always what? Capital. Let me write it a bit down here. We're supposed to get probabilities from a PDF we are going to write. But who owns these probabilities? A given random variable, what? X, capital letter. But we said, on one morning, X can be this. Another morning, X can be this. Another morning, X can be this. So the X we are dealing with can be any X value, anytime. Since it is X1, X2, X3, X4, X5, I will not put any number. I will just leave it as small x and close my brackets. Like that. That is the first statement. At least get that. Because when you don't write it correctly, you're not going to get marks. The moment you write both of them and they appear as capital letters, you're wrong. It's supposed to be this one capital, this one X equal to. We are not going to cram anything. And how will you be competent? Equal. After that, we write that curly bracket. After that, we put here a function that we are going to be using to obtain probabilities. Maybe it is x out of 16. Now, this is the function they use to get probabilities. This one, it can be anything. It can be x squared. It can be 16x squared. It can be anything. I've just tried to choose that. That's what I've just chosen. But this is what they use to generate probabilities. It can be anything. So I'll say that one is used what? That one is used to generate probabilities. Used to generate probabilities, hence can be anything. Hence can be any other expression. Someone can put there 16x squared, 13x cubed, 15 over x, anything, depending on the x values, of course. Now, after putting that function or the expression that is going to be used to obtain probabilities, you're supposed to put a comma. Remember, we said, those who read the statement, you recall when I said that these values of x, the x1, x2, x3, and blah blah, they are the ones we use to generate probabilities. So when you put a comma, you are supposed to bring these very x values, and remember, they fall under a certain range. They shouldn't go beyond a certain range. So I'm supposed to use the small x. There are people who use commas. There are people who use a semi-what? Colon. So when you find a comma, semicolon, pick what you want. So I'll say x equal to x1. Let me now use values. 1, 2, 3, 4, 5, then full stop. Because the range is specific, we don't want other things. 4, then 5, full stop. Period. Put the full stop there to show that there are no other values. Then someone may be like, what if we have other values? What we called elsewhere. Someone may be like, what if we have other values, semicolon, elsewhere? Or some examiners, what you people call item writers in the new curriculum, may put there otherwise, may put there elsewhere. Remember, here we put probabilities. We agreed that elsewhere, outside the range, the probability is supposed to be 0. That the probability when you substitute 6, when you substitute 7, when you substitute 5, when you substitute, 6, 7, 8, 9, 10, all those probabilities are zeros. This thing always disturbs people. Because someone is like, they are asking me the probability when x is equal to 6. So someone is like, hey, let me just bring this 6 and put it here. And I be like, the probability is 6 over 16. They even reduce and say the answer is 3 over 8. This is wrong because 6 was not part of the specific range. Anything outside the specific range, the probability is just 0, you just conclude. But remember, we are still in the English. We have not yet started the real numbers, how they are set and the calculations. So you literally get it, but at least get the literature. Don't just write things anyhowly. Don't know that here is supposed to be a semicolon, here a full stop, here curly brackets, here capital X, here small x. Elsewhere, or some people can use otherwise what it means, something like that. That the function or the expression used to generate any probabilities can be anything. They can even put there a combination. They can put there a permutation. You just need to be ready for anything. So before I proceed, because what I'm going to next, we are going to use this same function, but I'm going to something else, what they call individual probabilities. Do I have anyone with a question as far as this is concerned? Because I want to talk about individual probabilities and how individual probabilities can help us generate a probability distribution, or what they call a probability distribution table. And then maybe I also talk about the sketch because it is part of our learning outcomes. And then before I bring in a few properties, I think we shall have to do some little calculations. Yes, we shall have to do some little calculations, get probabilities. Then later we see things of mean, standard deviation, variance, and we shall end the lesson. So, any concern as far as this is concerned? I told you if you don't have any issues, say no issue, we proceed. Yes. Okay, people have said no issue. I've been trying to go through the chat. After all, I don't have a chat secretary. So you're supposed to bear that. Where are we? Where are we? Where are we? Where is the workbook? Okay. So I'm going to talk about individual probabilities. How do you get individual probabilities? Things are very easy. Discrete. The problem is with continuous. By the way, don't watch continuous before you watch integration. Yeah, our lessons of integration are also there. So before you watch continuous, make sure you watch integration because it's what is used that side. So how does someone get individual probabilities? Just want to show you the working individual probabilities. Remember we said that if at all you want to get the probability for our unknown variable x at a specific x value, this is the function used to generate probabilities. We agreed it is x over 16. So when the question says that, please get us the probability at x equal to 1. Remember, our range is 1 up to 5. So this is how you do it. You come and say probability capital X equal to, it is supposed to be AX, but X has been substituted with the what? With the 1. So also put here 1 and say equal to, also come and replace that X. You put 1 over 16 and you're done. And then you say math is hard. Discrete. That's why I wanted to cover it now. When people are just from school, because you just understand everything by default. But continuous, I integrate. If people are just coming from school after failing differentiation. So we record the details you people were at school. So I'm going to, those who will be in position to pay for the classes next week, because free classes are ending this week. Shall have another session in the afternoon, God willing. Then in the night, even via the weekend, we shall have. But next week, lessons are going to be paid for. You will join a group of the premium students. Those students have completed 80% of the syllabus, and they will start revising around October. The only thing we shall be remaining with are practicals of chemistry and doing project work. We shall just do project work at once, then we submit to their schools where they will register from. Those people are doing homeschooling. So those people are going to be in those groups. They're going to be your moderators. Anything you consult, they will help you. Trust me, none of them will go below 18 points. If at all the grading system is kept constant, they will pass. Because I already scare them. I've actually seen one here. I always scare them, telling them how hard things are, even when they are trying. Okay, so for x equal to 2, same things, 2 over 16, which you can later write as what? 1 over 8. Then at x equal to 3, you write things as I'm writing them, please. Let me actually write x4. There is 3 and 5. So yeah, you're supposed to come and be like p capital X. You write small x 0, 0 equal to 4, because it is the x value. Did you try again? Then you say 4 over 16. Then you get a quarter. Something like that. So you get this correct, provided this appears. Remember, we have not started any calculation. This is now what they call shaping. I'm shaping. By the time we begin the other things, we are good to go. That's how you get individual probabilities. Now, how do you construct a probability distribution? So constructing or drawing. So I'll give this 2. I'll say this is 2. Then I'll say constructing is 3. Then I'll say constructing. Constructing or drawing. A probability distribution. I'll stop there. Then I'll put in brackets the word table. Why is it in brackets? Putting it in brackets, I'm simply trying to communicate that when you find any task, any question, asking you to construct a probability distribution and it stops there, they are telling you to draw a probability distribution table. Period. Nothing else. So never overthink about that. And how is this supposed to be? This is the easiest thing ever in this topic. Why is it even part of the syllabus? Like, when you fail to understand this topic, you change combination. But if you fail to understand continuous, please keep around. It is understandable. People, you're not supposed to draw your table like this. You're supposed to use a ruler. Use a ruler. Let me put it here because some of you have a tendency of taking screenshots of the work. Use a ruler. Okay, so I'll come and say, here you simply put the x values. Then here you simply put the probability, something like that. You know that function, eh? Let me actually tell you something better. You come here and just put this, eh? You know why it's like that? Then I beg, you come here on the top of the table and put that thing. I'd forgotten, but I couldn't flap the table. I've just thought of it now, eh? X over what? X over 16. Put it on top of your table. Yes, then come and just substitute because there it will be understandable. So what are the values of x that we have from our function above? We have a value of 1, we have a value of 2, we have a value of 3, we have a value of a. People, what happened to me? I used to be a bright man. Hope I've not messed up this time round. You have 2, you have 3, you have 4, you have 5. You people, this is supposed to be small what? Small x. So to get the probabilities, we always just simply substitute where? In the function, You understand? It's like you're getting the individual probabilities and tabulating them. Simple as that. So here we'll have 1 over 16, 2 over 16, which will become 1 over 8. But even if you say 2 over 16, it is okay. Then here 3 over what? 16, 4 over 16, which is a quarter. Is a quarter. Then here you get 5 over what? 5 over 16. So when they tell you to draw this probability distribution table, I advise there are wiseacres who say that it's better to have the working. So what you do, get individual probabilities. After getting individual probabilities, draw the table of that format using a rule and you're done. Yes. So hope the table is okay. We can now proceed with the sketching. People, can we now sketch? Remember, we are sketching using the same things, eh? So people, can we sketch? Can we sketch the PDF? So you have refused to talk. Sketching a PDF, or what I call the p.m.f. Sketching it. You people, to sketch you need values of y, values of x. That's what you need. Values of y, values of x. But here we don't have y and we have x, but we don't have y. Who can tell us? That's the table we are supposed to use. That's the table we are supposed to use as we sketching, plotting, or what, but we usually sketch. Who can tell me where are we going to get the x? Because to sketch anything we need x and y, but we have x and it is x that is clear. What of y? Where are we going to get the y? What are we going to consider as y? Such things. Anyone to say something?
Recording in progress. Press.
But you people, you're not cooperative. You're not cooperative. Are you learning things for the first time? You just don't want to study? Are you learning this topic for the first time? Okay. So you people, you know how labelings have been, how people have always been labeling this, eh? So I'll come here and say, so we have said here we shall have our normal x values, but the question is, how are you going to do the plotting? Do they always start from 1? Yes, in most cases they do. So for our question that we have currently, it begins from 1, so I'll have a chance to have a 0. I'll put my 1, put my 2, I'll put my 3, I'll put my 4, I'll put my 5. Put my 4, I'll put my 5. Then those of you who have been following up the probabilities well, those ones. Remember, this is a simple sketch, eh? And you know they are going on as they are increasing because it is 1 over 16, 2 over 16, 3 over 16, 4 over 16, 5 over 16. They are just increasing. Though we have been reducing at some point. And it's me who said that reducing is not compulsory. So I'll put here a 0. This is just a sketch, so it shouldn't stress you. So the first one was just 1 over 16. This one is going to disturb me. Anyway, 1 over 16. The other one was 2 over 16, which was 1 over 8. And the other one was 3 over 16. The other one was 4 over 16, which was a quarter. Then the last one was 5 over 16. If people have better handwritings, you can rectify that. So these ones down, you all know they are values of what? They are values of x, small x. Eh? Then this one here, we have chosen to have the probabilities as the values of y. So y-axis, we have the probabilities. So that's what you put. So the question is, how do we sketch? So you all know 1 had a probability of 1 over 16, so you put a dot here, like normal plotting. 2 had the probability of 1 over 8. 3 had the probability of 3 over 16. 4 had the probability of a quarter. 5 had the probability of 5 over what? 5 over 16. So I'll put here a line, put here a line, That's how they plot. Put here a line. Put here a line. Hey, I've tried. The last one I've not even tried. But let me give it a second chance. See if somewhere here. It's just a sketch. Even you sketch, but for you just try to be perfect. So no need of a graph paper. Just use your answer booklet, something like that. That's how the discrete PDF, discrete p.m.f is sketched. So promise me, I want people to promise me that in case they tell you to get individual probabilities, you can get. When they tell you to convert the individual probabilities into a distribution table, you can. When they tell you to use that distribution table to sketch a PDF, you can sketch. I want people to just tell me in the chat, I promise, I promise, I promise, I promise. You just say, I promise, I promise, I promise, I promise. That's what I want. As Jonathan says something before I tell you the good news about this sketch. I want to see people in the chat saying, I promise, I promise, I promise, I promise. Okay, hope so. Now, someone wanted to say something, but they are not speaking. So I'll talk about what can we get from.
Yes, good afternoon, doctor and other creatures.
Yes.
My question is, doctor, what if
Mm.
this 1.6, what if I convert it to be 0.063?
It is not wise. Let me
Then
even. Is that your only question?
yes, teacher. Yes, doctor.
Okay, I've tried to mute you so that we avoid those echoes. Let me say this. In probabilities, it is wise enough to leave things in fraction form. Why? For when you look at 1 over 16, it has a perfect decimal, which is 0.0625. But when you look at 5 over 16, it is also having a perfect decimal. But you're going to come across very weird decimals. Because you'll be like, hey, Dr. Pot said it is okay to put things in decimal. Because the example, maybe I did, had perfect decimals. But the day you will have something like x over 15. When you put in 1 over 15 in the calculator, it has 0.0666, you get. The moment you round off a probability, you're bringing issues. So when you're dealing with this topic, try your level best, whether it is normal distribution, but for those things of normal and what, decimals are okay because there is that option of using tables, and tables have no fractions. So there you're good to go. But these other, especially the random variables, discrete and continuous, try your level best to cling on the what? To cling on the fractions. They are better. Okay. Now, I wanted to tell you some good news. You people who can tell me, when you're dealing with a frequency in statistics, what is the mode? People, what is the mode? No. Let me not ask that. Let me make it a very good question. It's a question. This is it. I want someone to give me a reason. Then we write our answer there. This is statistics, what you call descriptive statistics. So I'll put here X, I'll put here F, put here values 1, 2, 3, 4, 5, 6. I'll put here frequencies, put 20, 10, 5, 1, I'll put 70, I'll put 20, I'll put 35. So it's supposed to be 7. This is supposed to be 45. I want someone to raise up the hand. You tell us the mode and the reason, but I'm interested more in the reason. So don't just say, sir, for me I know the mode, but I don't know the reason. Then you're not competent. Let me tell you, the level of competence depends on, provided you go out of the crammers, you now become competent. Because now for you are an applicant of content. You understood, now you apply. Not like the other one who crammed and froze. Yes. That's why interviews is it. Yes, Ham. Yes, Ham.
The mode is 3
The mode is 3. Why?
because it has appeared multiple times.
Okay, that is the reason for
A
people who
lot
know
of
it by heart.
yes.
I want you to give me the okay. Let's formulate the reason together. Let me begin, then you finish. So the reason is that the mode is 3 because because 3 is the x value with what?
The x value tells how the point moves either to the right.
Yeah, so keep quiet. Very stupid. Is the x value with what? Eh? Who can
The
write
x
that word
value
in
with
the The what? Who can write that word in the chat very
with a
fast?
lot of chances.
With a lot of what? If people are not serious. Let me see if someone has said it in the chat. Highest frequency. That's what I wanted. That's what I wanted. Highest frequency. For this table, because this is a table of frequency. So it is the value of x with the highest what? The value of x with the highest frequency. Now I want someone who is good at contemplation to look at our this. Yes, I want someone to look at our this. You give us the mode with the reason. More than the reason, more than the reason. Let me see if it's present in the chat. I just take that. Anyone tell us the more than the reason? Yes, people, yes, you're saying mode is 5, but you're not giving me reasons. So is the value of x having the highest number of chances of happening? Yes. Highest probability, yes. So thank you for that. So you need that reason because when you have a task and the task is to get the mode, then this reason will be the response. And you know the response carries marks. You get it? But we shall see that in revision as we proceed. Right now we are still struggling with getting the content. Now, I want someone who has good knowledge of probability. Someone with good knowledge of probability to remind us about the concept of total probability. You people, what do you know about total probability? You tell me in the chat. What do you know about total probability? Before I say something about it. I want just someone to complete for us this statement that total probability is always what? Is always equals to what? Yeah, that is it. It is always 1. Now, this is where people always get disturbed writing this mathematically. Because you're talking of total probability. Question is, you look here, I want you now to listen. I want you to learn how this thing is written. I want you to learn how this thing is written. And this is how. Probabilities are written like this. P capital X equaling to small x, close brackets. When they say total probability, you're supposed to put the summation sign to mean probability. How does this summation sign look like? It is the sigma. It's called the sigma. You do this, you do this, you do this, and this. That's what they call the summation sign. But remember, yes, it is summation, meaning total probabilities. After adding all the possible probabilities, they say that the total of all probabilities is supposed to be 1. But it is not yet perfect. Why? You're supposed to come here and tell us for all the values of x present. If you don't mention that for all values of x, then the thing is not valid. Let me rewrite. Summation. Do this. That is the summation sign. And I've said, remember we are having a specific range of x values and all of them must have been substituted. So you're supposed to say, under the summation, you say all x. And after mentioning all x, you can now come and say equal to 1 in peace. In peace. Otherwise, problems. Capital X. This one is small x. Then you are supposed to come and say, therefore, here the total probability is a 1. Yeah. I want all of you to take a screenshot and post this on your status. Let me tell you, in your village, not more than 10 people can write this thing correctly. Either someone writes the summation sign poorly, either someone doesn't write capital X and small x where they are supposed to be, either someone forgets curved brackets, either someone forgets capital P, but most students forget the all X. Because when you don't say all X, then nothing has been done. So you take a screenshot, post on your status. Yes. Or put on your DP. Then you tag me. If you don't mention me, then I will not believe you. But don't tag me, just post it. Or let it be your wallpaper, let it be your everything. It's a very good expression. It can change your life academically as far as probability is concerned, because it's what we are going to be writing throughout all calculations. So, we shall add a statement. Yes, put it in WhatsApp groups, put it everywhere. Okay. Shall put a note and say very important note, so that the above formula, the above is used to obtain, the above is used to obtain values of unknown. The above is used to obtain values of unknowns. Values of unknowns, or what we call constants, in PDFs or p.m.fs. So as usual, you tell your parent the concept of total probability is written like that, and every time a question asks us to find the value of a constant or any unknown, it is the concept of total probability that we use, period. And I've told you, with a lot of practice, these things will become obvious. So you people, I'm done with the introduction. I'm done. We have used around 1 hour and a few minutes, and it is worth it. Because now when I begin calculating, those of you who have been with me, you know, I do an example. We agree that you can use the knowledge we have discussed to do other examples. You say yes, we do other things. Other than panicking with the introduction, we do a lot of examples and you don't even benefit. The main examples are supposed to come in discussions, not by the tutor, especially in the new curriculum. So, introduction, do a lot of numbers, interpret scenarios. Tugende maaso. Now we begin. We begin straight away with work. Hope you're seeing the screen. Let me see. According to these notes we are having, what is this thing? You can see there are 11 pages. We are done with the introduction. Now we are going to just calculate. I want people to be calm. Don't log off, though it's time. Our lessons are supposed, by the lessons are supposed to end at 1:30. I'm going to share the timetable. So, we are going to do these numbers. There are very few. Then, that is page 2. And on page 2, that's where we have the first exercise. And trust me, that exercise is yours. Then, even this second page, page 3, is just full of exercises. Now, on page 4, that's where we have the last target of the lesson. Expectations, variance, and everything. But I think we shall just do those ones at once. I'll teach you expectation, variance, and everything. I teach them at once. That will be page 4. See? Now, on page 5, there is a certain exercise. But for only mean, that's on page 5. Even this page, now here there are properties of mean, but me, I'm going to teach you things at once. Mean and its properties at once. Now here we have variance. Now variance also has properties. You get? Here they try to separate them, but me, I'm going to combine. Even here, properties of variance. You see now we're on page 8. And let me tell you, the moment properties of variance are done, I showed you how to sketch. The topic is going to be done. You see, what is coming next is the cumulative distribution function, which I will teach later. But trust me, remember it is cumulative and we're on page 10. Those who are seeing the screen, we're on page 10. That means we only have one page to complete the topic, but I will not panic. Otherwise, we can complete Discrete today in one lesson. But at least I want us to have the second lesson for the cumulative, so that people don't get confused. You get enough time, do probabilities, mean and variance and all properties, standard deviation, and yeah. And then here, lastly, there are the exercises, I think. Cumulative is the easiest. However, even what we are handling today needs a lot of time. So, don't get tired very fast. We are still together. Okay. Hope you're ready. Now, the real math. Probability distributions, discrete random variable. The p.d.f is discrete if it takes on specific values. Those are not in use. Total probability is 1. I told you that. And I remember telling you, every time you see small f of small x, remember telling you that is for p.d.f, and it is what we are handling. Here they are saying that the probability should not be great. What is this? Probability. They are saying that probability is either 0 or greater than 0, but it should not exceed 1. I think you people know that. Probability is either 0. Okay, probabilities are always between 0 and 1. You can never find probabilities in negative. You can never find a probability that is greater than 1. You know this from primary. When you toss a coin, you either get the head or no head. No head is 0, head is a half. But you cannot say negative. How? Okay. Now, examples. Straight away. A discrete random variable x. So this question is not serious because it has to have capital X there. Has a probability function this. Find the value of C. The moment they ask you to, you listen people, the moment they tell you to find the value of a constant C, you're supposed to use the concept of total what? Probability. Then here they were asking you to do the graph. But I'm not saying the graph in this book, but for us we are going to draw it. You get, every time they tell you that get the value of the constant C, total probability comes in. But someone may be like, but how are you going to do that thing of total probability? So let me write that and I show you what I mean. Here is our workbook. So example 1, very first. It has been this. This is cx squared, 0, semicolon or comma. This is 0, 1, 2, 3, 4, full stop. The semicolon elsewhere. Okay, yeah. And then the first question is saying find value of find C. C is a constant, C is an unknown. So total probability must come in. Now, a very organized math student should write this formula. That the summation, you can even write it like that. Summation P capital X equal to X is equal to 1. Don't forget that it is true for all what? Values of X. But I'm requesting, if you cannot recall this, please leave it. Let me begin with if you can't recall, leave it. Because when I say leave it, Someone may log off when I've said leave it. But I'm saying if you can't recall, other than writing something wrong, if you can't recall, kindly leave it. When someone is like, I leave that, I do what? Yet it's the concept we are supposed to use. That's a very good question. All you need to understand that when I add all probabilities, I get 1. Now the question is, how do you get probabilities? You should have the other concept and recall that Paul Tudor said the function they always put here is the function used to generate what? Probabilities. And how are individual probabilities generated? Individual probabilities are generated when we substitute for these x values here in that function, if I may call it so. You understand? So when you add all the individual probabilities and equate them to 1, you can get the value of x. Remember I told you it can be x over 16, x over 15, 15x, 16x, 16x squared, 15x squared, anything. So here it's now cx squared. Maybe it was 14, maybe 16, maybe 13 or anything. So we are going to substitute for each x value, like as if we are getting individual probabilities. Then we add all of them to bring out the thing of summation, then equate to 1. And in that way, we shall be in position to get the value of what? X. Let's hear from, I don't know, is it Mweslai? Yes, unmute and speak.
Uh, Good afternoon, guys. So, like, my question was,
Who are you calling guys? Even me, I'm part of them.
okay,
You say,
good
you
afternoon,
say,
everyone.
you say good afternoon, doctor, and other guys and other creatures. You say good afternoon, doctor, and other creatures.
Good afternoon, doctor and fellow students. So, that equation, shouldn't there be an x between the summation and the probability and the piece?
And the what?
Like,
You see,
for
you
I
can't
was
be.
told that
Don't even continue. You're going. Don't even tell us who told you. You're going to. How is it called? That is very bad. The X you're meaning is for something else. If you recall very well, it was for expectation, isn't it? That is something else.
oh,
See, you're just simply dealing with probabilities. You see the issues of learning things just mere picturing them. That's the problem. And that's how you leave a math paper saying, I used what the teacher gave us. That thing is very bad. Let me tell you people, students of math in the country are always 50,000. 50,000. But A's can never go beyond 3,000. 3,000. Not even 10% of students who do math. Why? This math, you're not supposed to cram. Understand things from first principles. Actually, let me tell you, the people who actually pass it that way are not even 5%. That's why I told you to include luck in your Lord's prayer. Because luck is it all. Okay. Now, we are going to come and substitute for individual properties. Sorry, individual probabilities. The values are the values are 0 to 4. Then the generator is cx squared. When I add all the individual probabilities from the individual values of x, I'm supposed to get 1. That is the concept of total probability. I start. I'll begin with C. It is cx squared. The first value of x is a 0, and I'll square it. I add. I get the individual probability for x equal to 1. The generator is cx squared, so I write C. X value is 1 squared plus C. X squared. X value is 2 squared plus cx squared. X value is 3. I square. Plus C. X value is 4 square. Oh, those probabilities are supposed to give us 1. But that's the only statement you need to understand. Let me see those people who get it from the chat and those who need me to pardon. But if you need me to pardon, then you are not easy to deal with. Because what haven't I said? Unless it has been network. Who gets it? I will not pardon because I will say the same words. That person has the best reply. When I say who gets it, giving me the value of C is confirmation that you finally get it. Yes, and that's what is supposed to be done. Simply total probability. I'm waiting for more one person. I want 5 people to tell me they get it, we proceed. Okay. People have refused to respond. Okay. Now after this, C0 squared is 0. I won't hear about this in polynomials. I'm not repeating. C1 squared is C. C2 squared is 4C. C3 squared is 9C. C4 squared is 16C equal to 1. That is 5, that is 25, that is 30. C equal to 1. Yeah, then you get the value of C as 1 over 30. You come and get a mark for applying the concept of total probability, a mark for the evidence of working, a mark or a score for the value of C. And yeah, so that's how we use the concept of probability to find the values of unknown. Substitute for individual probabilities, add all of them, equate to 1. Where do you substitute them? In the probability generator. Where is the probability generator? Is what you write first after the curly bracket. Bana, byonna mbyogedde biweddeyo. Ekimala kimala. Okay. So they are saying, and draw the graph of that. So let me draw the graph for only this part. For only this part. Then it is you people are going to do number 2. I do number 3. I do number 4. Okay, let's draw the graph. But you all know for us to draw the graph, we need a table. So we are going to first draw our table, and you know how the table looks like. So that has been the first part, find C. Then part B, they want the graph. You want the graph of that. A. So you all know to draw the graph. So here it was c x squared. So you can be like 1 over 30 x squared. It is better to write it that way. I don't want you to be compressive mathematicians who say x squared over 30. You be organized and put out the coefficient. It is healthy and it is called mathematical aura. Yes. Put the coefficient out, leave the x squared the other side. So I'll come and say x, then I have here capital P, x that. Hey, the values, we had 0, we had 1, we had 2, we had 3, we had 4. So you start substituting. When you substitute for 0, probability remains 0. When you substitute for 1, probability is 1 over 30. When you substitute 2, probability is 4 over 30, making it 2 over 15. When you substitute 3, probability is 9 over 30, making it a 3 over 10. When you substitute for 4, it is 16 over 30, making it 8 over 15. Remember telling you this is a sketch. If it is a sketch, you put those very values. Don't waste your time. The moment you notice that it is discrete, how do you know it is discrete? It was for a specific range of values, 0 to 4 and nothing more. So how do you plot? You people are aware. You people are aware that we are going to do this, put here this, because we have our table already, it's defined. Put here x, the values are from 0 to 4. This is 1, this is 2, this is 3, this is 4, this is 0, this is 1 over 30, mm, 2 over 15, eh? Is it 2 over 15, 3 over 10? Two over 15, 3 over 10, 8 over 15. 0 and 0, I'll put here 0. Most students have given me reports that they have issues with mechanics. So mechanics, next week, we shall do mechanics next week. When people have settled, when people have paid. Yes, that's when we shall do mechanics. So come here, put that. Then 2 over 15. Sorry.
Uh-huh.
Put that. So if they say sketch and hence say the mode, you people know what to do. Oh. But as you're sketching, you're supposed to try to be neat, even when it is a sketch. Try your level best. So that's how they expect it to be. So you know the value, because that is the highest probability, the mode is the x value 4. That's if they need it. That's how you sketch, eh? So you'll be told that it is better you first show the working of how the individual probabilities were obtained, which is also very okay. I taught you that and I'm not ready to repeat. But as we are finding probabilities, I'll show you. This is just a sample. Get the ideas, get the statements, so that in the near future you can reminisce and be like, oh, this is what Paul Tutor said, so it is okay. Kali. This number 2. People, number 2. Please, Boniface, you leave my screen. You remove those green lines you've put. I don't like it. You rather do anything, but leave my screen alone. Okay. Value of k, and hence draw the graph of f of x. You people, let me ask, according to what you're seeing on the screen, as far as getting the value of x and plotting is concerned for that specific question, can you fail any question that comes like that? Whether they remove c and put k, whether they remove x squared and put x, or put x cubed, or they put the c down and it is x squared over c, or they put the c up and it is c over x squared. Do you need me to do also such examples? Or you know now the concept that substitute for individual probabilities, you add, after adding, equate to 1. Get the constant. When you get the constant and they want to plot, draw the table. From the table, you sketch. You tell me. Can you apply? But tell us how much. You people, the whole holiday is just 25 for math. 25,000 for the holiday, even if your holiday is a year. 25,000. Yeah, then chemistry, same thing, 25k. Yes, and we shall complete all work of next term. And you also get exposed to the work you're supposed to learn as far as senior 5 is concerned. Yeah, that is it. You people, what does Nara mean? I'm seeing Nara, no, what do you mean? You be like Joram Kawes, you say got the concept. That is understandable. I may not recall what I really asked and need response for. Okay. So you do that in your free time. So this is part of the assignment. Hope you take a screenshot and you can revisit later, because the answers are even there after all. Okay. Now, question 3, it's what I want to talk about. It's what I want to talk about. You people, you look at this question. I really don't even want to discuss much about it because it is here. You take a screenshot, I explain. Maybe you talk about it later. Okay. Okay, so this question is very easy. They're telling you a random variable x of discrete probability distribution is given by, they are giving you the probability at 1, which is this, probability at 2, which is equal to the probability at 3, both of which are 0.1. They're giving you the probability of 4, which is the same as the probability at 5, both of which are c. Do you get the point? Here they just want to test, provided they are asking for the value of a constant. You cannot escape the concept of total probability. You like it or not. About drawing the graph, this will be yours. We've now drawn 2 of them, so I don't expect it to be an issue anymore. And we said if you cannot recall this, you don't write it. After all, even this person forgot to put there that all values of x. How do you deal with the concept of total probability? Come and get the probability of what? Of 0.2 at 1. Add there the probability at 2, which is the same as probability at 3, both of which are 0.1. So you add 0.1 twice. The 0.1, the first 0.1 is for x equal to 2. The second 0.1 is for x equal to 3. After all, they have the same value. Now come and add these ones of 4. The first c is for 4. The second c is for 5. equate to 1. Get the value of C as this. I told you in polynomials that the most difficult math to explain is the math that is already typed and I'm doing what I'm doing. But there are some things that look obvious to me, not to you. So I want people to let me know whether whatever I've said about this number, as far as getting the value of C is concerned, whether it is okay. If it is okay, I go to 4. I want to surround 5 people, 5 representatives. You tell me if it is okay. I've tried my level best. So 5 people, only one person is saying it's okay. Getting C, more 2. More 1. Okay, we go to 4. That is done. Don't waste time there. So after, I'm going to talk about 4, and after 4, I will talk about finding probabilities. There are students who have not yet studied series, and there are students who have not yet studied a lot of things. And this example 4 has a concept of sum to infinity. Whether this R has a meaning and the A has a meaning, because R is common ratio and A is first term. But those things have not yet been taught. But trust me, when you combine the knowledge you have so far on probability, and then you combine the knowledge that you will get when I start teaching series, when you combine either knowledge, you'll be in position to understand what this example 4 and its solution is about. So I will leave it at that and go to the next thing. That is finding probabilities. Look at this question. It's what I'm beginning with. This one, example 1. So I said that the random variable is usually x. Usually x means not always, but most of the times it is x. So for this question, they gave us y. So for the y, you just treat it as what? For the y, you simply treat it as x. Just like the way you've been treating x. So here on top, we have the values of x. Someone may be like, but some are negatives, but you told us they can never be negatives. No, we said probabilities can never be negatives, but the other specific values can be negatives. You get the point? So, straight away, I'm going to waste my time and give this time. Then other examples, we are going to be just going through what the writer was writing. As simple as that. Simply what the writer was writing. Okay, let's go to our workbook. I put so this is a concept about finding probabilities. Finding probabilities. Finding them is the easiest. You recall when I taught individual probabilities? So this is simply going to be an application of everything. So the example that we have is very good in that it's talking about a new random variable y, so that you learn as a student that it's not always supposed to be x. So that if an exam comes and they have used q, you can literally modify. Look here. So don't forget that we always have here small x. So if it is y, it is small y. Don't forget that is always capital P, capital X, hence capital Y equal to small x and small y. Okay, sorry for that short break. So let's put in the values from -3 to 1. Let's put the probabilities to 0.1, 0.25, 0.3. Where are we? Here we have 0.1, 0.25, we have 0.3, we have 0.15, then we have a. Yeah, that was the question. So I'll put here that was the question. And now, part A, they want you to get the value of A. Value of A is a constant, A is a certain unknown. We said that for that, we always use the concept of what? Total probability. Now, what you have here, these ones I'm ticking in green, these ones are already probabilities. Because you see, they are falling under that row for probabilities. So we expect that their total is 1. So this is very easy. You simply just come and add all of them. You'll be like 0.1 plus 0.25 plus 0.3 plus 0.15 plus A. Those are the probabilities. Their total is 1. Use a calculator, 0.3, that is 65, you get 0.8. Hope that's what people are getting, 0.8. Plus that, then you get your A as 0.2, like that. For this, they can say 1 mark for total probability, the other score for the value of A. And you're done. Now you know that you have your worker value here. Your worker value there is a 0.2. Let's see what other questions are. This is Roman 2, this is 3 and 4, and this is Roman 5. And trust me, when we get done with this question, the rest of the things are going to be easy. Just follow up and see how this mega example is done. So that one is -3 to 0. -3 to 0, but you're supposed to be careful about those values. Because they are saying they want the probability from -3 less than or equal to y. This y is supposed to be small, but if they use capital, you just ignore that, then less than 0. I don't know if people know the difference between less than or equal to and less than. You can see that was the question. Here they used less than or equal to. Here they used less than 0. Who can tell us the values of y this question is interested in? Who can tell us? Who can tell us? Let's maintain the capital here. Who can tell us the values of y they are interested in for such a question? According to that table of ours, you look at that table from -3 to 1. So in consideration of that range, which values of y are they interested in? Yes, say something.
-3 to -1.
-3 to -1, exactly. Because they are saying less than or They are saying greater than or equal to 3, -3. So -3 is part. But when they say y is less than 0, then 0 is not supposed to be part. As simple as that. Hey, -3 is part, 0 is not part. So that means we are going to make such a statement. I don't know if people will get it, but I know they will. After you knowing that they are interested in those values from -3 to -1, you come and say that these people want me to get the probability when y is -3, then they want me to add on the probability when y is -2, and these people also want me to get the probability when y is -1. This formula is very important, and if you can get it, then please write it, provided you can maintain these capital letters y, because you know why it's like that. I taught that in the introduction. -3 is part, 0 is not part, because it's supposed to be less, so -1. Those three values. Then you go to your table and you understand. You go to your table and substitute. Come here and be like this probability. You look at your table. Are you seeing? You have 0.1, 0.25, and 0.3. You add those. 0.1 plus 0.25 plus 0.3. Then you conclude and be like, the probability that you people need is 0.65. Someone will be like, hey, but sir, you said fractions are better in probability. Because the question has already provided its things in decimals, so who am I to Isaac? The other one was a choice of answer, in case it is a word problem, maybe. So I want around 5 people to tell me in the chat that that has been understood. We go to the next part. 3 to 5 people. 3 to 5. Should we proceed? Actually, people had the ideas. All those who have said the ranges, I think it is okay now. Those who mentioned the ranges are even more than 3, so we can proceed. Now the next thing is here. They are saying y greater than -1. So as usual, you write me the values they want. Y greater than -1. Which ones do they want? They want the probability of y greater than -1. So which probabilities do they want according to this table of ours? They want the probability of y greater than -1. They want the probability of y greater than -1. Yeah, 0 and 1. Hey, you people are serious. So then the probability of when y is 0, then they want the probability when y is 1. You come and say at 0 it is 1.5, then at 1 is 0.2, because we have just found that. You come and conclude y greater than -1. The answer is 0.35. Get a score for substitution, score for that. Yes, thanks for following, people. So we go to D. What is D saying? You look at this. They're saying P -1 less y less 1. Oh, this question is very good. -1 this 1. What do they want? You look at our table. What do they want? -1 less than y less than 1. They just want 0. This is very good. 0, which is 0.15. Score of identification, score of output. Before I go to the mode, let me put mine. Probability of y less than 1 or equal to 1. Then I want the probability of y greater than negative 3, greater than or equal to negative 3. Then I want the opposites. I want someone who can unmute and take us through these ones. These ones are now very important. Less than 1. People, before we go to the mode, the last one will be the mode. Then we shall give a reason, the person who will tell us that. So, let me pinch the screen very well. Y less than or equal to 1. Let's begin with that. Y less than or equal to 1. What do they want? Let me see if someone is going to write what I want to see in the chat. People, probability of y less than or equal to 1. What do they want? Probability of y less than or equal to 1. What do they want? Or what are we considering? If I've tried to pinch the screen, you'll be very fast. Total probability, that's the word I wanted. You people who are saying negative 3 to 1, you are doing me a disservice. They want a total probability. Yes, negative 3 to 1 is very correct, but you're not going to add all those things. Yes. You don't need to. I don't know if people are realizing that when they say y less than or equal to 1, they want all values, which all values will give you total probability. What of y greater than or equal to negative 3? Do you also realize that that is all values, hence total probability? So I want you to be such kinds of students who are not just going to cram things and just break down things like that. So here it is the same as total probability. So it is just 1. And you get your scores. Total probability is 1. Yeah. Then I want someone to tell us which values do they want? Which values do they want? Now, this is where I want your attention. When they say y less than 1, which values do they want? Or what do you think these people want us to do as a shortcut? When they say y less than 1, they want negative 3, negative 2, negative 1, and 0 without 1. So they want all probabilities except the probability of 1. You know that people are getting me. When they say probability of y less than 1, for this question, it's like they want all other probabilities except the probability of 1. So they are meaning you get the total probability, which is 1. Then remove the probability for 1. I don't know whether you understand that. Before you tell me whether you're understanding that, let's go to the next H. H is saying the probability of y greater than 3. Sorry, -3, not 3. It is -3 here because we don't have 3 in our values. So do you see that? Y greater than -3. Do you see that? It's like they want all probabilities for values except -3. But this one only works for extremities, like the first value and the last value. I don't want you to use the same techniques on some other values which are not on extremes. I've mentioned that, I'm not repeating. And trust me, if these things are confusing, for you do what you know. You be like probability at -2 plus probability at -1 plus probability at 0 plus probability at 1. You get the same answer. I'm just giving you that sense of thinking ahead of the normal thinking. So you can also realize that for y greater than -3, it's like saying get all probabilities that add up to 1, then remove the probability of y equal to -3. I want to see people in the chat telling me it is okay. I want 5 people, as usual. 5 people, it's okay. I just want to see it's okay, it's okay, it's okay, it's okay. Oh, you say got it, got it, got it, got it. Those are 3. More 2. Yes, if whether it's that trick that works for you, whether it's the other thing of adding them individually, that one is also very okay. Okay. So you can try out the other manual one, adding them one by one. So yeah, I will say 1 minus 0.2, and I get 0.8. The answer then here I will say 1 minus, I think it was 0.1, get 0.9. Get your 2 scores for each. You may even get a score for this because it is not an everyday working. So what is the mode, people? What is the mode? What is the mode with the reason? What is the mode? What is the mode? What is the mode? What is the mode with the reason? Someone just unmute and say it because it is something we've been singing from the beginning of the lesson. What is the mode with the reason? What is the mode with the reason? That's what people are saying. Mode is -1. At least you attach the reason. So mode is -1, that is right. But I want to see if people learned how reasons are written, in case the question asks them to respond. Of course, you're supposed to respond to tasks, so response is a must. Because it appears most. Those things are wrong. Someone saying highest probability. But those things of being lazy are the things that are going to bring you hard time. For me, I don't teach this as students. How can I ask you for the reason and you say total probability? Might occurs most. I'm also tired. I'm not going to say that. You find out on your own. I said that long time. Acting as if I've not said anything yet. Okay. So all these values, I think we had, all those ones we had. Now, when you look at this question, it is the same thing. It is the same thing. Are you seeing this one? Value of C you can find. This one you can. This one you can. I've talked about these signs and everything. Even mode you can. The only thing that is new as far as this question is concerned is this thing. And I'm going to comment about it. Yes, like that. What if something is looking like that? What do you do? It is x greater than 2, the other one is less or equal to 4. I was teaching probability last term, and I think I forgot to talk about conditioned probability. I never, it's not forgetting, but I think time never allowed. People had started reporting back. So probability, let's write and say probability of x, this is greater than 2, given that x is less than or equal to 4. This is what you do. Very easy. You are supposed to get the intersection of the two. You understand? You're supposed to get the intersection of the two. So it'd be like, I need the probability x greater than 2 intersection x x less than or equal to 4 out of the probability of this, because it is coming last. So it's supposed to be probability of that. You understand? I know that people get it. Why is it like that? I'll tell people where this comes from. So I'll remind people that this comes from probability. Then when they say that they need the probability of A given B, you know what you do? You get the probability of A intersection B out of the probability of B. Like that. Like you get the intersection of those two as the numerator. Then you bring this one that is coming last as the denominator. Since it came last, let it be the denominator. Then the numerator, let's have the intersection. But for probabilities, you may need to do something extra. Like you need to rewrite this. Like they need the probabilities from when values are greater than 2 up to when they are less than or equal to 4. So you can either leave it like that and get the probabilities, or so someone can say, let me rewrite this. They are saying we are beginning from 2 and x should be greater than 2, but it should be less than or equal to 4 out of this. But none of this has marks. They may want the substitution first. So I think this is okay. The most disturbing thing here is how we are converting this to this, like how we are converting this numerator to this numerator. But it's okay. We are looking for an intersection of x greater than 2 and x less than or equal to 4. Someone may not even waste their time. Someone may say, oh, they want values between x greater than 2 and x less than or equal to 4. Someone is like, that is 3 and 4, isn't it? 3 and 4 are greater than 2 and are less than or equal to 4. So someone may just come and say, let us just put here probability of 3 plus the probability of 4. Yeah, and you're done. Probability of 3, probability of 4, you're done. Out of this, you know how to deal with this, you know how to deal with that. You people, is that cheat code enough for you to attempt this one too? This one. Is it enough? Is it enough for you to attempt that? I want some people to tell me yes, it is enough. I want some people to tell me yes, it is enough in the chat. Is it enough for you to proceed? Okay, those people are enough. I think we can go to the next thing. So I'll skip all this. So let's see this question. So all these numbers are yours as assignment. So serious person is taking screenshots. Everywhere I'm not doing, take screenshots. Like that kind of number, you take a screenshot and do it in your free time. It is there. I've given you the chance. Take a screenshot in your free time, sit down and do. Come up with your notes. Attend these lessons once. Have your notes. When you need to review notes. You get? Okay, so question 3. These are things we have been dealing with. Value of k is obvious. This is obvious, 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 obvious. This has been talked about. So you do that in your free time. Exercise. So you also take a screenshot of that. So you realize you have a lot to do. So I pity people. I pity people. I pity people. But you people, this question required someone to first get the value of K. You get it by total probability. Then they started asking individual probabilities. Yeah, which I don't. I believe if people look at such working, they can even come out with their own working because they are the same things. Okay, I believe the screenshot is done. So you also take that screenshot because this is exercise, so it is a must. So you take a screenshot of that, even the answers are here. So that means you can refer and be like, okay. Are you seeing this format of the PDF? It is understandable. The values they are giving you here, 12, 13, and 14, they are the specific range. Then this kx is the generator. So you can get the constant using the concept of total probability. Okay. This is more work. Where does it stop? So you also take a screenshot of that. Hope it comes out clearly. So those who don't attend lessons. So I remember telling you that your curriculum is competence-based. So as in assessment, you should expect scenarios. But in mathematics so far, there is a proposal that they want section A to have computation tasks like questions of old curriculum, so that section B is scenarios, because the math paper full of scenarios with all these serious concepts we are supposed to cover. It may be a very hard paper and it may not accompany all work that is in principal math. So in the end, you may even end up having two papers because the content is serious. Topics are 27. You cannot put that in a single paper unless you reduce them to around 10. So just be ready for anything. So respect both old curriculum questions and scenarios as far as mathematics is concerned. So let me tell you about the expected value. I tell you about the variance, their properties, standard deviation is obvious, and we end the class. Yeah, we shall not do anything more than that, but these ones are the easiest, yeah? Because you need them. Yeah, just know we are done with the hardest part of discrete probability. These things of mean and standard deviation, variance, I don't see anything hard there, literally. Okay, so let's go to the next thing very fast. So we have around 5 minutes to end the lesson, only 5. So you stay on, stay patient. So I'm going to say other parameters. What are those other parameters that we look at? So the other parameters, the first one is going to be mean. Or what we call the expectation of x. Of course, x is capital. I told you we are going to be representing capital and small. Then instead of expectation, people can remove expectation and put expected value. So mean, expected value of x, expectation of x, it is the same thing. Now, these things copy the concept of total probability. You understand? You all know that the concept of total probability looks like this: summation of this, isn't it? Then here we have all x. You get the point? Now, this is what expectation of x does. Expectation of x, this is how they denote it. Expectation of x. This is how I used to recall. So let me write it here. Expectation of x equals, I'm going to add something important. Now, for me, I used to write it like this. I used to write it like this. That's how I used to write it, expectation of x. Why like that? Because it could help me recall that x fits itself somewhere as I'm getting expectation of x. That's how I used to write it. I used to begin it with the x there and then. So I could come and recall that when I'm getting expectation, I have my small x somewhere here. That's where it comes and fits itself. That's why the other person was like, but sir, for me, they told me that there is x between the summation sign and p. That person had crammed. So you should learn that x comes in when you're getting expectation of x, which is the same as expected value of x, which is the same as mean. This is what happens. And that's what we are going to be doing. But you recall, in case you are not sure of these things, please don't write it. I'm always going to show you a way of how you can escape that. So you should recall that this is what this thing is called, the sigma. It means the summation. Yeah? If they ask you the name of the sign, it is sigma. Then what does it mean? It means summation. That's why you always add. So people will call it sigma or summation sign. It's like asking you theta. You be like, how is it read? Theta. What does it mean? An angle of anything, angle of deviation, angle of inclination, anything. So those are Greek letters that we make use of. So you're supposed to, what are you supposed to do? You always get this one is a value of x. So I will say value of x. And then this is a corresponding probability. These things are very easy. They are just fun even. You people just imagine you get x value times corresponding probability, you add x value times corresponding probability, you add x value corresponding probability, like that, x value corresponding probability, x value corresponding probability, x value corresponding probability. That's what you're supposed to do, and things are just done and very easy. Yeah. Now, application. That is enough of the stories. But before I go to that, you people first agree with me or first believe me that that's how mean is calculated. Yes, that's how mean is calculated. I'll wait to go to variance, but I'll come back to variance later. Let me use this very chance to teach you the properties of mean. Because I believe now you know that mean is the expected value or expectation of x, where this x is capital. Okay, now the first property. What if they want expectation of a constant, maybe a? Yes. What if they want expectation of a constant like A? The expectation of the constant A is that very letter A. You understand? Iggy. What if the question asks, what is the expectation of 2? Of course, you've said 2. So that's what we expect. What is the expectation of 4? Of course, you're saying expectation of course, we also expect 4. etc. What is the expectation of negative 3? Of course, we expect negative 3. So it is it. You understand? The other one was generally expectation of what? Of X. We proceed. Part B, the other property. What if they tell you the expectation of A X? Something like that. What if that's what they want? This one is very easy. You simply bring the A out because expectation of A is still A. Then multiply it by the expectation of X, which has a formula. You understand? To put it in clear things, they can say, you get the expectation of 5x. The expectation of 5 is just 5, so we put it out. And since it is multiplication, we multiply it by the expectation of what? Of x. That is also very clear. What if they make it extra and add a constant? That is part C. And say maybe expectation of a capital X plus B, another constant. They're the same things we are going to do. These things don't change. It's like they want the expectation of X plus the expectation of B. But the expectation of X, we are supposed to get the A out, then the expectation of X, you get? Expectation of B is just B. There, even if I don't use values, you now know what they want. You now know what they want. I don't expect that to be a very big problem. Hey. Iggy. E 3x minus 4. What do they want? And the expectation of 3x minus the expectation of 4. Expectation of 3x is 3 times the expectation of what? Of x. Expectation of 4 is just 4. Like that. Lastly, and etc. What if they make it worse? And it is ax squared plus bx plus c. I taught you polynomials. So these are friendly things. This one, let me do it at once. I bring a out, then I get the expectation of x squared plus I put the b out, then times the expectation of x plus expectation of c, which is just c, and etc. People, don't you see that these things are easy? I want someone to tell me mean and its properties. Yes, it is a long word, but you say it. You say that mean, this is a very good profile pic. You say that mean and its properties are okay. We are 20 and it's the number I want to maintain till we finish. Because now we are going to just write examples around 2. We do variance. Variance is also very easy. And yeah, the lesson will be done. When someone tell me mean and its properties, okay. Mean and its properties, okay. You people, you are on. I don't want you to be lazy. You say something. Mean and its properties, okay. Mean and its properties are okay. That's what I want. Mean and its properties are okay. Mean and its properties are okay. Only one person has said, so I'm also going to stop there. If you people are not cooperative. Some of you are just copying and pasting your people's comments. Okay, think we are done. So you said expectation. I think you can see this first take example. These ones we know. You can see example 1, they say the discrete random variable x has this probability distribution. I said they can put table or they may not. So you consider that. So they said find the expectation E of x. So the same formula was used as usual, but then I told you something easy. Now this is what you're supposed to do. You get x times its corresponding probability. You add the x times its corresponding probability. You add the x times its corresponding probability. You add until you finish all of them. People, it's what was done here. Negative 2 times its corresponding probability. They added. Why are they adding? Because of the summation. Why are they multiplying the x and its probability? Because that's what the formula is saying. That get the x value multiplied by its probability. Keep on adding and treating this probabilities the same way. Probability times x times corresponding probability plus x times corresponding probability plus x times corresponding probability plus x times corresponding probability, and they got this as the expectation. I told you the hardest math to explain is math that has been just already typed and then explained. But I think it is okay. People, should I assume that it is okay? Or should I assume it is okay? Let me see. Okay. Now here they were asking the value of C. Now, you people, this question is sensitive. You people, this question is sensitive. When you look at this question, these values of Y, they were working for this generator. That if you really want to get probabilities for these values, you are supposed to substitute in that generator. Then, for these other Y values, if you want to get the probabilities, this is now a new generator. I don't know whether people are getting. So it is the same question. It is one random variable Y, but this variable has two p.d.f.s. Why are they two? There are two, each with its own set of values. That if you're considering Y to be 1 to 3, you're supposed to use that generator in green. And when you're considering values of Y from 4 to 7, you're supposed to use this generator. You understand? That's why when they were getting these probabilities, something else was done. I don't know if people can really relate how these people were getting these values. I want us to look at their table. You see, people, for me, I told you how they get these tables. So for me, I just think everything is okay. We invested a lot in the introduction. From 1 to 3, to get probability, they just want CY. That is from 1 to 3. From 4 to 7, they want C into 8 minus Y. something like that. So if I may ask, 1 to 3, do you see that it's what they try to do? That wherever they were as y, they were putting 1, 2, and 3. That's why the probabilities are 1C, 2C, and 3C, because that's what they wanted. Then for these other ones, when you put here 4, 8 minus 4 is 4. That's why we have here 4C. When you put here 5, 8 minus 5 is 3. That's why we have here 3C. When you put here 6, 8 minus 6 is 2. That's why we have here 2C. And when you put here 7, it is 1. That's why we have here 1C. So is this table also okay? Is that table also okay? Do you see that technique in case the question comes with 2 PDFs but the same random variable? Is that okay? Someone has said very okay. Okay, we proceed. So when they ask you to get the value of C, the thing of total probability should come in. If you don't recall this, please don't write it. Don't write it if you don't recall it. Please don't. How does total probability work? Come in this row of probabilities, add all of them, equate to 1, get the value of C. When you get the value of C, if you want to make your work easier, you redraw the table. You even have now another technique. You can now redraw the table because you have the value of C. Because when you redraw the table, things are going to be very, very easy. Because you'll be having all of them. Let me tell you this. When you redraw the table, what I want you to avoid are these things. 1 times C, 1 times 2C, 3C, 4C. In your calculation, these are things I don't want to see. But when you get 1 over 16 and you redraw the table, you can literally find the expectation of y. What people here called the mean and gave it a letter mu. So we shall come and add something here. That mean has something else, and that is the mu. That letter mu is for mean. I don't know how I forgot that. But mu is also used for mean. So you people, I don't know if we are together. You should be taking screenshots. You follow up after you sit down, make your notes, topic done. So assuming for you redrew the table. So just come, put 1 over 16, you put 1 over 8, you put 3 over 16, you put a quarter, you put 3 over 16, you put a eighth, you put 1 over 16. You understand? So people, I'm asking, is this mean or the expectation of y also okay? Is it also okay? There I will need you to tell me because it is already typed work. So we are trying to make sense of it. But in the end, you need to make your own notes. So is that okay too? We go. So, as you can see, here coins were tossed. X times probability plus X times probability plus X times probability plus X times probability. Here they are telling you a fair coin is tossed 3 times. Write out the probability distribution for the number of heads obtained, and hence obtain the expected number of heads. I want to ask people, you look at this question 3. They're saying a fair coin is tossed 3 times. That's why we are having 0, 1, 2, 3. Then they are saying, write out the probability distribution for the number of heads X obtained.
Found this on the web for
Someone who can explain to us where are they getting this value? 1 over 8, 3 over 8, 3 over 8, 1 over 8. I want to see whether people can reason to their maximum. as you also think about this, they are saying a family plans to have 4 children. Given that X is the number of girls in the family, find the expected number of girls. It's now what they call word problem. So since they're supposed to have 4 children, we're supposed to consider no child, 1 child, 2 children, 3 children, 4 children. But I want to know, where are these people getting the 1/16 and all these other values? Even here, you're tossing the coin 3 times. So we consider not tossing first time, second time, third time. Where are they getting the 1/8, the 1/16? Now here it is brain test. Brain test. Because when you know how they are getting those probabilities, these things of expectation are the easiest, because you just get X value times corresponding probability and add all of them and complete. I want to see whether people can say something. I want to know, do people know where those things are being obtained from? I doubt whether people know. I doubt whether people know. Eh, 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 eh. I doubt whether people know. People, do you? Do you? If you don't, you say we don't, so that I educate you. And why these questions were taking us to mean, it's because of this expected, yeah? This word expected, that word. Expected, 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 expected. I don't. If we knew, we would have told you. But that statement is very long. It's even longer than I don't. Why don't you just say I don't? Okay, let me educate you people. So, this book, they were just putting values, but this is the behind the scenes. Let me teach you the behind the what? Behind the scenes. Behind the scenes, only at our online school. Okay. They are saying that the family, where we know they are saying the coin is going to be tossed 3 times. And they want only the heads obtained. So we are going to come. We are having our coin here. So we are going to first deal with the coin 3 times. So we are having our coin here. You all know the coin has the heads. The coin has the what? The tails. And they are saying they are tossing it 3 times. This is the first time. You understand? Imagine they toss and get the head. First time, assume they toss and get the tail. We go second time. Assuming after the first time, after getting the head, they toss for the second time and get the head. They toss, imagine they get the what? The tail. We go. After getting the tail, they toss and get the what? The head. They toss and get the tail. You know these things. That was the second time. Now, third time, which is the last one. People, sorry about that. I think we have, I don't know. It was network. And unfortunately, we are not taking the screenshots. I don't know. But anyway, the good thing, people have been following and taking notes. I always advise you to take notes from these classes, so that after the class, you have the notes already and you can keep reviewing those with time. So we are talking about this. We are talking of the coin. Then we said, this is your coin. And it's having the head, the tail, for the first time you can get the head or the tail. Then for the second time, you get something also, head or tail, even here, head or tail. And what you're learning right now is a lifetime concept. It is something that disturbs people so much. Most of you studied tree diagram. So even for the third time, head, tail, head, tail, head, tail, head, head, tail. So for the head, you all know probabilities here are half. You know, if people are aware, because there are only two things, so everywhere I have I have 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 have. You get? So if I'm to put things here at the end, this one is head, head, head 3 times. This is head, head, tail. And this is head, tail, head. This is head, tail, and tail. This is tail, head, head. This is tail, head, tail. This is tail, tail, head. This is tail, tail, and tail. At least people know that. So that's what they mean by tossing a coin 3 times. You have seen the first time, you've seen the second time, and the third time. Now, when they say that their interest is in the number of heads obtained, you're supposed to consider 0 heads, understand? 1 head, 2 heads, and 3 heads. So when we come to our tree diagram, to begin with, who can tell me? You're going to write it in this form, triple H, like these are things I expect you to write in the chat. Who can tell me where is 0 head? Because according to the table here, let me remove this. We are on this number 3, this one. It's the number we are handling, this. So I'm like, where is 0 head? Because they want heads. 0 head, 1 head, like that. After the 3 times. Triple T. You understand? So you people, let us look at triple T. Do you realize that if we want to get the value of triple T, you look here. If we want to get the value of triple T, we are supposed to come, say a half times a half times a half. And what do we get? We get 1/8. That is the 1/8 in that table. You understand? That is the 1/8 in that table. So this one has been sorted. Then where are the 3 heads? The 3 heads, those ones are clear. They are here. Are you seeing them? This was 0 heads because the tails are 3. Now we also want 3 heads, which are only those ones. Same thing. A half times a half times a half, giving us 1/8, which is also here. 1/8, so those ones are sorted. Now the problem is about this one. 1 head and 2 tails. So let us see. 1 head. Let's look for 1 head. Here we have 1 head. Here we have 1 head. Even here we have 1 head. But remember, all of them, since it is a half everywhere, each of those ones is 1/8. This one is 1/8, 1/8, 1/8, because they are halves and they are 3 times. So if 1 head is appearing 3 times, remember this one is 1/8, even this one is 1/8, even this one is 1/8. So when you add those 3, that's how you come up with what? The 3/8. This one for the 1 head. So when I go to 2 heads here, 2 heads, let me use different ink. Here, 2 heads, 2 heads, 2 heads. They're also appearing 3 times, and each is 1/8. When we add all of them, that's how we come out with this what? 1/8. So realize this table will carry a lot of marks. And one thing I request, if you can show this working, because it may be hard for you, because after all, you're supposed to do this very thing as side work for you to fill that table. So in your solution, feel free, draw this tree diagram. However, I'll teach you in the future, we shall find time and revise about probability. I tell you how you can escape use of a tree diagram. Yes, I'll teach you. By the way, you people, you should admit in holiday lessons shall be long, 3 to 4 hours. There are nights where I shall teach for 6 hours because you're not at school. This is holiday that is very short and we are supposed to cover a lot. So we are not supposed to do the school system. You're supposed to just get some good time and split these topics into 2 to 3. 2 lessons, topic done. 3 lessons, topic done. Maximum of 5 lessons, because a lot is supposed to be covered. So you're supposed to be patient enough. We shall enjoy in senior 6 revise. We shall jazz. I'll give you career guidance. I'll guide you on a lot of things. We shall have stories, but right now we are in the struggle for content. So you should admit, stay silent, listen, understand. Yeah. We shall see other things. These are videos that your siblings will watch. So we are supposed to record them in respect to those people so that they find something good in the future, something that is purely academic. Yeah. So, hope that is okay. So concerning this second one for the, trust me, after getting those probabilities, expectation is easy because expectation is just probability times its corresponding x value plus deal with the probabilities, all of them the same way. So I'm not going to do this one for the family. I'm not going to do this one for the family. I expect it is very obvious because they are saying a family plans to have 4 children and they are considering number of girls. That means you're going to consider producing for the first time, second time, and third time. Then you consider no girl, 1 girl, 2 girls, 3 girls, 4 girls. I think you people can do that. This is about a family that is want to have 4 children. That means the trials of producing are supposed to be 4. So first time, because here we have boy and girl. First time, boy. Second time, first time boy or girl. Second time boy or girl. Third time boy or girl. Still third time boy or girl. Fourth 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 time boy or girl. You understand? But that is just one part. So there is the other part. But let me tell you, there is a shortcut to all these things. But I'll teach you that with time. Someone is like, hey, what if the question says 10 of them? Of course it can't, because even if you decide to use a shortcut, it will be too much. So usually the maximum is 4. It's that time. Then fourth time. Boy, girl. Someone is like, now someone who has been dozing and just woken up is like, hey, what are those things? You will know. So that is it. So these are the comments I expect in the chat, or I want people to tell me whether the other one of the coins was okay and how the table was filled. And you also make more research about the tree diagram for the family and confirm that that's how the table is supposed to look like, and hence finally getting the expectation. Yeah, that has been some nice idea. So is the idea of the tree diagram in 2 tables okay? And can you work on that of tree diagram later and confirm whether the table is also right? Hey, I'm only getting comments from Gladys, Gift, and Comfort. What of the other 15 people? What's wrong? Okay, good luck. Yeah, good numbers commented. So now these things of boxes are going to be easy for you, because even here we have 2 colors, red and blue. So you try out that. You can take a screenshot and later find out. Should be faster taking screenshots. We have tried the hardest thing. So even these example 6, you're supposed to try them out on your own. Even this one, a gambling game. All these things are in tree diagrams. So whoever will be attending such lessons in the future, you take screenshots, answers are there. You pause a bit, You pause the video, take a screenshot, attempt later. Make your notes. The exercise for whatever we have been doing is here. You've seen how, so that is also an assignment. Yes, you take a screenshot of that. Those are more examples. The properties of the mean, these ones we finished. The ones we finished. But you can see there are more numbers there. You can take a screenshot. And you people, after for us, we've done the expectation thing. You don't need the what was I going to say? After we have done the expectation thing, you don't need okay. People, are you seeing this? This question, they gave you values of x and probabilities. They asked expectation. So I think you can see x value times corresponding probability plus x value times corresponding probability plus x value times corresponding probability, and it was obtained. Now, when they asked expectation of 5x, remember we said pull out the 5, multiply it by expectation of x, which is 2.2, and get 11. You understand? Then when they asked this expectation of 4x plus 6, remember telling you put out the 4, multiply it by the expectation of x plus 6. Why plus 6? The expectation of 6 is still 6. They substituted and came up with 14.8. But you see that even the application is easy. Even here, expectation of 6x minus 2. Put the 6 out, multiply it by the expectation of x, Subtract expectation of 2, which is already a 2, and this is what is here. And they came up with 1.6. How do they get the expectation? They were getting x value times corresponding probability plus expectation times corresponding probability plus x value plus a corresponding probability. X value times corresponding probability. You people, do you see that these things are easy? I want 5 comments saying okay. I want only 5 comments saying okay. 5 comments only saying okay. Say things are okay. You have that book in PDF. I'll share it in the group. Hey, thank you if you have. Hey, I've received you people. I want more 6 okays. I want more 4. I want 10 of them. So more 4. Those people who are on but following quietly. And if I say I want 10 okays, don't send more than 1 and you're just 1 person. Okay. So that's where I'm going to end the lesson. So next time, I want to begin with this interest. Remember, we are running with 2 lessons to end this. So we shall do this variance, which is very easy because things here are the same. We shall do variance, that is next time. We do variance. Remember me, I combine variance and its properties. So I'll combine variance and its properties just like I've combined the mean and its properties. We do variance and its properties very fast. We do examples. We shall see there are some good assignments. You understand? I'd say this is the one supposed to be for later. It is on page 10. That means we have 1 page to cover and the concepts of variance. So I will begin the lesson with good concepts of variance. You understand them well so that you easily connect the PDF to a C.D.F. You easily connect small f of x to capital F of x, as we say. So you take a screenshot of this because this is where we have assignment for things of mean. You also take that screenshot. You only look for these things of mean. Those ones with mean, and you need to practice. We've derived the discrete well. We've talked about mean, its properties, getting different probabilities. You've learned the technique of tree diagrams into a table. I think if I put your head, if I put variance into your heads, you're going to burst and you will not pick anything, which is not wise at all. At least let's shift it to next time. After all, continuous probability that is supposed to come next is already on our drive. Yes, it's already present there on our drive. So you just need to pay just 25 shillings. Sorry, 25,000 shillings. Access the drive for the whole holiday, for the whole of next term. Until next holiday when more work has been uploaded, then we turn it off. Unless someone has anything to say, otherwise I'm done. I'm done. Just to make you go with confidence, as far as the syllabus book is concerned, you're supposed to describe a discrete and explain the properties. We have done that. You must calculate mean and mode. That has been done. Don't mind about median. Here I was just trying to teach you, but you know these things of interquartile range, they are there in statistics, but I just wanted you to learn what are measures of central location, what are measures of dispersion, so that you learn them. So even this has been handled, but median is not part. It was just a matter of learning them. Sketching, you've learned. So according to whatever you're supposed to learn in this topic, we are remaining with C.D.F. and variance. Of course, variance is standard deviation. Without variance, you can't have standard deviation. You just get the positive square root, as we shall see. So we are just remaining with 1 lesson. You know, the introduction is always the longest, but the moment we introduce, the other things are just Chap chap. These things of coins were done. Tabulating probability distribution, I taught this very class. So to me, it has been a success. Any comments before we leave? Thanks, Dr. Oka. So closing prayer from Gladys Gift. Gladys Gift, unmute and give us a closing prayer. I'll share this book with time. Yes.
Good afternoon, Doctor, and the
Mm.
other fellow creatures. Let us humble ourselves and we pray. Father Lord, we want to thank you for this day. We want to thank you for the gift of life you have given unto us. We want to thank you for the lesson that we are from having. Father Lord, we pray that whatever we have learned, may it stick in our mind, and whenever we are asked for it, we may be able to apply it accordingly. Be with us and protect us. I pray all this believing and trusting in Lord Jesus Christ. Amen.
Yes, thank you for the word of prayer. Those people want to make research on the topics we are covering. I think you can see this is our library. You just go to our website. Biology books are there. Biology ebooks, you have textbook notes, you can see. So far I've put functional approach. I'm soon putting Michael Kent, understanding biology, and Susan Toole. Then biology assignments, chemistry textbooks, you can see there are those of organic, physical, and inorganic. Chemistry notes, 98 assignments are there, are 4. You see, your notes are not easy to come up with because they are supposed to relate to the curriculum. They should have scenarios, they should have computation tasks and everything. Math textbooks, can see pure applied math assignments, they are also there. Physics, same thing. I think we have there Ruja Monka, Staneko, and Parker, and all the other things are still going to get uploaded. So if someone may need to access it, the site, let me just write it here. But I'm really sorry that we lost the notes we have been using for Discrete. But simply revisit the recording, watch it at a very high speed. But when you're watching this work, watch it at speeds of ×2, ×4. Though ×4 is only on the website. But literally you can't listen to anything. This is what I either ×1.5, 1.75, or ×1.25. Just to increase the speed as you're copying notes, as you're reviewing. So that's the end of the lesson. Let me sign out and tell you how to access the site. So I sign out as Paul Tutor, a chemistry math teacher at that online school. And the website is chemmathonline.com. chemmathonline.com. Reach there, create an account. But I'm soon releasing a video that is going to be on YouTube, taking you through all steps on how the site is supposed to be navigated. Yes. But most of you have your people at your schools who introduce you to this. They have all knowledge about the site. So they can literally brief you about everything. Yeah. Otherwise, bye. Maybe the other thing is about the drive. Those who are going to pay and access it, you may not need the website because even the drive has work. You can see here. I don't know if you're seeing that screen. Under the Senior 5 Principal Math, there is Term 1 work, Term 2 work, Term 3 work, and then revision and e-library. So Applied Math, you find there textbooks of Applied Math. Pure Math, you find there textbooks of what? Pure Math. Even if it is chemistry, if I come here on the chemistry folder of Senior 5, this one, it also has Term 1 work, Term 2 work, Term 3 work, revision and e-library. Still, when you check the e-library, you find there books of physical chemistry, organic and inorganic. And I'll soon add there those of practical. The site is for everyone, but you cannot access videos, you just get notes. The drive is for those who have paid. If you want to access the videos from the website, you pay from the website, and all those options will be clear in the YouTube video. If you're not fine with paying from the website to access the work from there, you pay to my numbers and give you access to the drive and access it for the holiday and next term, and that's where the subscription stops. So it is 25k for 4 months. That means each month you've paid 5k approximately. Isn't that fair? Otherwise, have a nice day. Let me put my number. Someone is asking, how am I supposed to pay? Maybe you go with my number. I don't always want to put it here because I get a lot of messages and fail to respond to them, which is too bad. So this is my number, but I prefer WhatsApp calls. It is even clear in this workbook. So this is my number and WhatsApp calls, not WhatsApp messages. I prefer a call, you pay, I add you there, and then we get done deal. WhatsApp call. So no other questions. Bye bye. Stop share. Meeting has ended.